Evening, self Nasiba Noori. Hope you all are fine and healthy. I feel so privileged to extend my warm welcome to the 71st webinar of the weekly webinar series organized by IEEE Malabar Subsection, association with IEEE Malabar Hub and KMCT College of Engineering for Women, Kalandur. I would fortunately welcome our speaker, Mr. Karimulla Shaik, Chairman IEEE Malabar Subsection, Dr. Sabik, and all the participants for today's session. We have with us Mr. Karimulla Shaik to speak us about the Big Data, Spark, or advanced technologies and use cases. Mr. Karimulla Shaik graduated from REC Calicut with MTech Honors degree in Power Electronics. He has 20+ years of experience in TCS and currently working as an enterprise data architect in TCS Analytics and Insight Division. Past 2 decades, he led various large-scale transformation programs across US, UK, and Australia geographies for BFSI and retail clients. He is certified in insurance domain and big data, Snowflake, data science, and AL or ML technologies. His primary area of interest are data science, AL or ML, big data clouds, Snowflakes, data architecture, and data modeling. He also worked as a program manager to lead 150+ team members and received Best Auditor Award in TRICE, TCS, and also various other service commitment awards. So we have with us Mr. Karimulla Shaik to speak us about big data, Spark, or advanced technologies. It's my great honor and pleasure to invite Mr. Karimulla Shaik for today's session. Over to you, sir.
Yeah, thank you very much. Yeah, good evening, everyone. So welcome to the session on Big Data, Spark, Advanced Technologies and Use Cases. Yeah, before going to this topic, let me share a couple of stories. So one of my friend, Mr. Sridhar, he's one of the best LIC agent in India. He got many awards. And he came to Chennai for his business, and on his way back to his native place in Ongole in Andhra Pradesh. So it was a night, 9 o'clock, and he thought of having dinner in the nearby city. He need to travel another 1 hour. So he had dinner, and then he started driving. And unfortunately, he was a little bit, his car went away off road, and the car got upside down, and he was unconscious. And another story, okay, another friend of mine, his name is Ram. So he has an aqua business, and he used to come to Pondicherry for testing that aqua seeds for the quality test before he purchased the seeds. And he has the aqua plants in his native at Ongole. Okay, so he used to drive from Ongole to Pondicherry. It's a 350 kilometers distance. So he used to spend, he used to drive at over 90 kilometers per hour. And one fine day, okay, while he's on high speed, so he reached Nellore, and unfortunately there was a iron ore truck. It used to come from Karnataka to dispose that at Nellore port. So he met an accident with that truck. I mean, so he applied the brakes. It was not sufficient. He hit that truck, and the airbags opened. He is unconscious, and the truck driver left away from there. So now both these people are unconscious, and let's see whether Spark can do anything here for both these cases. Okay, let me go to these scenarios. Okay, so today's agenda is that a big data technologies recap that I had in the last session, and the Spark overview, key architectures, use cases, and case study. So this is the last time I have covered that overall this big data technologies, the way duck cutting came up with a Nudge and the Google file system white paper and MapReduce. By combining MapReduce with Nudge, the Hadoop came in first in 2006. Then later the Cloudera came, and they have that Hadoop user interface they introduced. And then duck cutting started working with the Cloudera. And as I told, there is a HBase, another third white paper that came up from Google, and there are different technologies from Hive, from Facebook, from Yahoo. And so this was the journey they had. So last time majorly I have covered this the storage perspective of in Hadoop. Means the Hadoop, all the data is getting stored in that HDFS file system. So today I am going to cover that how this processing is happening in Hadoop. Okay. So this MapReduce is the first processing engine. It came in Hadoop. It's majorly for the batch data processing perspective. So how it is to do is, let's say you have this input data, it's a various file systems that in the Hadoop HDFS. So the way the data is to distribute is it's in the format of blocks of 128 MB. So each block of data is 128 MB. And this is called as a physical division of data. So chunking that blocks into 128 MBs. So there is another layer called a logical division. So what that means is when you chunk this data, let's take this, hi, hello, how are you? What are you doing? Are you okay? So when I chunk this data, first block has that 128 MBs and second block has the rest of that, assume this one, okay? In that 130, 128 went up and the rest of came to this block 2. So if you look into this, this is the incomplete data. That means what are you doing? It's got split. So what this input split will do is it will take the full data from block 1 and the first line from the block 2. So with this only, this entire sentence will be complete. So this is called this input split. So it's a logical division of data. So input split will have this B1 plus B2's first line, and input split 2 will have that rest of the data in B2. So this is the MapReduce flow. So we have this input split 1 and input split 2. Take an example of, we need to identify based on this given input data, we need to see how many Hadoop, okay, there is a, okay, how many people working in the Hadoop, how many on SAP, like this, the one we need to come up to identify this number of people working in these technologies. So here first, this is the input split, means input of K1, V1 means, K1 means key value pair. So this is K1 is that offset of each line. Okay, each line will have the offset. Okay, and this V1 is the full line of this. So that is the value. So next, when we go to this map, it will split this data into each word. So this is what that list of K2 and the V2 keys. And then in the next place, sort and spill means, so it will sort this data came in the previous phase and it will sort here. And spill means it will store this data into a local file system. Means it's working on Linux, it will store in the Linux. Next, in this reducer phase, what it will do is it will shuffle, means it will copy this data from map phase to reduce phase. So it copied all this data here. And this merge and sort means it will sort this data and merge for each keyword. Okay, so this is what we have. K2 is the key and the list of V2, how many times this data science, D science is repeated. So finally, it will consolidate the data and it will store here. That's the final reducer phase. So if you see here, this D science or data science has 4 people are working like this. So this is the flow in this MapReduce. So this is the best used for this batch processing. And later in the last session, I told that Arun Murthy, he came up with this AN architecture, combining this Hadoop one that has the HDFS and the MapReduce along with YAN. They came up with this Hadoop file system HDFS2. And this YAN and HDFS2 is widely used in this batch, interactive, online streaming, all the places. So what is this YAN architecture? If you look into this, okay, this is a simple command that a client or user is giving to this Hadoop system. Okay, YAN architecture. What it's saying is, hey, Hadoop, take this data.txt file and put it in a Hadoop file system. This is the simple command. So what this client will do is, a client will go and see, say that this resource manager is the first point of contact in this YAN architecture. Let me give a little bit of background of here. So yes, this AN architecture will have that two types of components or daemons. So one is that long-lived daemons, and the second one is this short-lived daemons. So this resource manager is a resource manager, and this node managers are this long-lived daemons, and this app master and this container are short-lived daemons. Means once their job is over, they will clean up themselves. And so each cluster is nothing but a group of connected processing devices. So that my processing device might be our laptop also. So group of connected devices called as a cluster. So in a cluster, there will be one resource manager always. And this usually there will be n number of node managers that equals to that number of data nodes in that cluster. Okay. So this client will come, and for him, this resource manager is the first point of contact. He say, I want to process this request. So resource manager will go and interact with this node manager. So node manager job, as I said in the last call, so he used to maintain the metadata for entire this cluster, and also he need to take care of cluster management. So he will tell that which block has the free capacity, and all the request metadata will pass to resource manager, and resource managers will give this back to the client. So now client will take this information and the requested this input split data, and also this the jars that he need to use to process this request. All this he will take and he will store into HDFS file system, and then he will go and tell this resource manager, yeah, I have submitted my job. So this resource manager have this scheduler to schedule all the jobs, and application manager. And this application manager job is to launch this app master. So this app master will launch by application manager, and he will come back and tell this resource manager is, yeah, I have registered in this cluster. So that is the number 6. So then, okay, he will tell, yeah, app master, go to this HDFS, and you have set of input splits, you have the jars, and pick it up all of them and start processing this. So app master say, yeah, very good, boss, I have all the details. So can you please allocate me some resources to me? So he will request to negotiate for the resource. Okay, again, resource manager, he's a program manager. Okay, he's a kind of a project manager in this cluster. He will go and tell this node manager, he's a node manager is like a project lead. So he will tell this project lead node manager, hey, can you go and launch this containers? So this containers will be launched and managed by this node manager. So once this containers launched, this app master will go and he will put all this as requested files, means the programs called jars in this containers. And these are the one will execute in this, all our MapReduce code will execute in this containers. So then this in the number 11, it will take all the data, input split data. Here this mappers and the reducer. Mappers means it will process this, and in reducer, it will finally consolidate this data here. And so once this job is it's in progress, this app master will go and update the status to client, means how much percentage of work is completed here. So once 100% work completes, all these containers, short-lived daemons, as I told, it will get clean up. So this is the high-level AN architecture, how this data is getting processed, what I told earlier in the MapReduce. So these are very important points that we need to understand. Like there is a resource manager, there is node manager, there is a container, and there is the app master. So then coming to Apache Spark. So what is Spark? So it's a Spark is a very fast, okay, very fast instance. So in the MapReduce, all the things is happening in the disk, okay. Whereas in Spark, everything is happening inside the RAM, okay. That's why it's a very fast. It's a general. General means it can be used for any purpose, ETL, ELT, and you can run the SQLs, any purpose you can use this one. And it's unified. Unified means you can write a simple 50 lines of code to achieve anything, either ETL or transformation, ELT or SQLs or dashboards, anything you can achieve with this one. So it's a in-memory engine, and then it will do this large-scale data processing framework for massive distributed and parallel computing purpose. So this harnessing power of cheap memory. So why this Spark become very popular is okay. Nowadays, earlier days the memory is used to be very costly. Now storage and memory become cheap, so they are using this power of this cheap memory. And this Spark was written in Scala. And also there is a Java and Python and R versions also available, means you can write the code in these languages as well. So if you look into the split of these languages, 70% of data is in the 70% of code in Scala, and just 14% in Python and 9% in the Java, and the other R and others has that 7%. So what it means is, yeah, they have written very high-level APIs. Means you no need to rewrite the code. Okay, they have this concept called object-oriented and function-based. This Scala used to call as object-oriented and function-based language. So you can reuse these functions. Okay, and there is a APIs are available. So you can just pass the inputs and call this API, and it will give the output. So this has many people worked on this Spark for developing this Spark language. There are 36K of commits and 13, 19. Hello.
Sir?
Yeah. Okay. Yeah, and many lines of lakhs of codes was written. And the main contributors for this one is that, okay, you see Berkeley University, and then this Cloudera is the another company. And majorly this Databricks is the very big contributors for this Spark. And this Spark is 10 to 100 times faster than MapReduce. Means if you use the power of disk means if you store this process of each processing, if you store into a disk, then it's a 10 time. But if you store into memory after processing of each phase, each step, then it will be, if you store it that in a RAM, it is 100 times faster. Okay, so let me give this a brief history of, so this Spark has started in UC Berkeley University as a PhD research paper. And then the Databricks came and they worked on this, and finally they donated this to Apache Software Foundation. It's a open source code. Anyone can go and take this code and they can work on, okay, they can download their laptop and they can use this one. And this initially there was a Spark one came, it has that SQLs and machine learning and graphics. And then this SQL has the capability introduced with data frames and data sets. And the ML pipelines. These were additions added in this 2015. And then in 2016, Spark 2 came in. Okay, Spark 2. Yeah, in this Spark, we have various components like Spark core. Okay, we used to call Spark core, and Spark SQL, Spark machine learning, and Spark graphics. So earlier we used to write each construct separately. In Apache Spark 2, what they introduced is there is a Spark session is introduced. That means once you create a construct or object, it means on a class you need to create an object. So once you create an object on a Spark session, with that you can go and interact with Spark SQL or Spark streaming and anything you can interact with that. Okay, so those features came in. And in 10th June 2020, they have introduced Spark 3. It's a majorly, it's a for performance improvements capabilities they have added. And this is the bottom graph is this contributors per month on Spark. Okay, so this in a peak around in the end of 2015, 139 contributors were there, and in average there is a monthly there was 50. Over 50 to 70 contributors are contributing to Spark. So why Spark? Okay, beyond MapReduce. As I told earlier, it's a MapReduce is only for batch processing, and it's more complex and it's more like ad hoc nature, and real-time streaming processing. It's a very difficult to achieve. Okay, so since it's majorly for batch and it's not providing these other capabilities, that's where this Spark came in here. Even if you look into this below picture, this we have the Hadoop file system, and here if you want to do as I shown in this MapReduce flow, there is many phases you need to perform in that. So whereas if you look into this picture, you have the file system, you copied that file into a memory, and you have done some transformation, and you have stored again into another memory. Finally, you applied some action or result. What is the outcome of that? So the outcome you have stored into a kind of a Cassandra or Elasticsearch DB, or directly from this Elasticsearch DB using Kibana. It's a visualization tool. You can see this final graphs out of this data. Okay, so this Spark is it's a lazy computation, and it's in memory. That means it will scan data only once, and then it use this RAM for reusing that data. So it will not come and hit that database every time. Okay, avoids the data hitting the HTTP all means. Okay, so that's why this is a efficient pipelining. Okay, so if you look into this pillars of Spark, so Spark has two main pillars. So the first one is called RDD, or resilient distributed data set. What it means is, so resilient means if data in memory is lost, it can be recreated. Okay, so I will show some examples in the down slides. Okay, so just understand this one. So data can be recreated. It can even it's lost, and it's means it can store this in memory data across the cluster. And a data set means the initial data can come from a file or can be created using some programming language. And then RDDs are these fundamental units of data in Spark. What this RDD means, let's say you have a file, some comma separated file or some data. Okay, so Spark has the capability to read this data and create a resilient distributed data set. Okay, so this is a kind of RDD we used to call. It's like some object or some kind of a representation of your data, like you have Excel or CSV, same thing. It will be stored in a RDD format in a RAM within the Spark. Then they will use this for doing creating some new RDDs by applying some transformations or some filters, anything. Okay, everything is happens inside the RAM. Okay, RDDs are the fundamental units of data in Spark. Most Spark programming consists of performing operations on these RDDs. So next, this all about RDDs. This is the core. So this, as I told earlier, this RDD we have. This is a first fundamental block. So with the data that came as an input from CSV file, this RDD will get created. And then, so after applying some transformation like a filter, map, okay, if you want to see that, okay, in a supermarket, what are the FMCG like soaps or some creams, how many it's got sold. If you apply that filter, it will give that filter data into a new RDD. Sorry. And am I audible?
Yes, sir.
Okay. Yeah. So, and then we can apply some actions on top of this data, and we can store this as a different kinds of files also. So, and this is a lazy evaluated. I will explain this. And so this data is can be partitioned and persisted in the memory. So these are immutable, means once you create this RDD, you cannot change this. Only thing we can do is we can apply some filter, some transformation, and we need to create another RDD. So we cannot change RDDs. These are immutables. And fault tolerance were the concept of lineage. So second pillar is DAG, direct acyclic group. So what it means is, so we have created first take an example of this RDD1, RDD2, this some transformation happened, RDD2 came, and from here we created 3, 4, and from here 5, 6 like this. So this entire is if we want to execute this in a batch, we need to write a one batch job. So this entire is a one batch job. This first set called a one stage, and this is second stage, this is third stage. We have 3 stages, and each one within this stage, to create this RDD, another RDD, we need to apply some transformations. And this is red color is the action. Like if you want to see some count, something, it's a action. Okay. So this subset is called as a, okay, this full is a job, and this each subset is called as a task. Okay. And so this direct acyclic groups are, so, okay, we have the node means it's a RDD partition called as node. We have edge means we have transformations on top of data. So acyclic means a graph cannot return to the old partition. Okay. So in next slide, okay. And here, if we have in this RDDs, we have 2 types of things. One is this transformations, another one is actions. So transformations means on this RDD, as I said, it's these are immutables. You can apply kind of a map or filter transformation. If you want to filter some data, you can apply the filter. Means on the same data, it's everything is achieved within one single line of code. Okay, you have millions of records in data in the first RDD. By writing a one single line of code, you can apply this filter and you can create a new RDD. Same thing, a map. Let's say we have this GST concept. So the price of a goods, we have a price, and we need to achieving for the gross price of that, we need to apply this, let's say one, it's a 10% is GST means 1.1 into the price of this. So this gives this gross price of this goods. Okay. So this can be applied in the map. You can say that take this price and multiply with 1.1. So this can be applied across all the records and it will create a new RDD. So the actions means the next one is if you want to see the number of counts in that RDD, or if you want to see, I want to sample some 100 records in that RDD, it is, we can say take some 100. And collect means return any array of elements. So like this, we have various actions in this. If you look into this small example, how it is works, okay. So this Spark context, later we came with this in the Spark 2, it's a Spark session, okay. And Spark session inbuilt, we have Spark context. Take an example, this we have Spark context, it's like a class. Okay, we are creating using a new function. We are creating one object called SC. Okay, the object name is given as Spark context. The object is SC. And on top of this SC, we have inbuilt functions. We are saying that a text file means take this HDFS file from here and read this text file and create a new RDD called file. So file is a new RDD. So all this data in this file, it loaded into a RDD called file. If we want to see how many errors in that files, we can take in this RDD file. We have applied the filter. In the filter, we are saying contains errors. Okay, how many records has errors? Though I created another RDD called errors. So this is the new RDD. I can cache this data in this RAM if I want to do further operation on top of that for faster performance. And then I can say errors.count, means I want to see how many records got errored. So this count is that action, and others, these are the transformation. The filter is a transformation. So as I said, file and errors are the two RDDs we created. So if the right side picture, if we look into this, there is a Spark context we have, and we have the file or collection of data. With that, we create an RDD, and then on this RDD, we applied a transformation. And again, we created one more RDD. Initial, we have file, and later we created one more RDD called errors. Like this, we can apply multiple transformation, multiple RDDs we can create. Finally, we can apply an action to get the counts or whatever maybe it's required. So this is where this how this Spark is works. So the other concept is called data lineage. Means, so we have a RDD we created, and then we applied some filter and we created filtered RDD. Finally, we have this count, it's an action. So when we created this task, whatever this job, right, it will not execute and it will not create unless we say trigger this action, okay? Until that, what it will do is, it will create a lineage, means for this action, what is the previous step I need to do, okay? I need to do this filtered, I need to create filtered RDD. For this, what is the prerequisite? I need to create this RDD. That means I need to read this spam.txt data, and I need to create this base RDD. So this entire thing is a kind of lineage. And this, okay, when you call a transformation, Spark does not execute it immediately. Instead, it creates a lineage. A lineage in the form of a direct acyclic group stored in driver in the Spark keeps track of what all transformation has to be applied on RDD. So once we execute this, once this action applies, then only the previous things will get executed. So that's where in Spark, they used to say that even something fails also, or if something data lost also, it can be recreated, because they have the concept of this lineage. With this, they are recreating. And then this terminology is as similar to in ARM architecture I have explained in earlier. So we have this different terminologies like a driver program, Spark context, cluster manager, deploy mode. Means, so this driver program is as similar to app master in the ARM architecture. We have a driver program. So this driver program has the Spark context. Means here this main program, any language we used to have a main program. So this main program will get initiated here in this driver program. And then this master node or Spark master as like a resource manager in the ARM architecture. Here we have this Spark master. It will act, it will take care of controlling entire this cluster. And we have this worker node, so it's similar to that node manager in the ARM architecture. And then we have a Spark worker. Okay, it's a name node, data node. And the executor is nothing but a cluster in this ARM architecture, okay? So this all are this data nodes as similar to ARM architecture. So this Spark architecture is it's nothing but it's a implemented extended version of ARM architecture. Everything is similar whatever there in that architecture. Okay. And of the other things, this is this a deploy mode. They have two types of deploy mode, client and cluster mode. So client mode is for development. If a project is in the development phase, we use this client mode. Cluster mode means it's a production based system. So in this cluster mode, this yarn will go and sit inside this cluster. Whereas in this client mode, this yarn will sit on outside of this cluster. That's the difference. So yeah, if we go into this, we have a couple of points to, okay. So I explained all of them. Okay, I told this job is nothing but a high level overall job in that direct acyclic group. This task is the each sub piece of that job is called task. And we have partition is this partition of data, okay, data unit called partition. Okay, the stage is that it's a group of tasks is called a stage, and a group of all the stages called as a job. So there are different way of executing this Spark. One is this standalone mode, another is Spark on YARN mode. Means here in this YARN mode, as I told you previously, here this YARN or this application master sits inside the cluster, whereas in this standalone mode, it is it's sitting outside of this cluster. Okay, that's what the difference. So this cycle of this Spark application, okay, yeah, similar to earlier in the AN architecture I explained. So when this user submits a request, okay, the Spark submit launches a driver, that is the main program will get launched here. And the driver invokes main, creates Spark session. With this Spark session, we can connect to this Spark context, Spark SQL, Spark stream, anything. We have data sets, transformations, and actions. And the driver contacts this cluster manager for resources. And the cluster manager launches executors for drivers, same as this AN architecture. And finally, we have this worker node and the executors and tasks. These are the this is the action of this job is called a task. Okay. So this, what is this? Why Spark SQL came in picture is, okay. So this RDD is it's difficult to understand, and people are more familiar with SQL kind of SQLs in real time in corporate kind of companies, big companies. So that's the reason they introduced this data frame. So data frame means in a Java, C, C++, we have the class or structures. So those structures will create as a kind of a table. Okay, it's represent as kind of a table, those structures. And those structures, from the structure, a data frame will get created. And it will behave like a table. On the top of the table, it's easy to write a SQL statement. So, okay. So it's nothing but we are converting our classes into a kind of table structures, and from on top of that, we are writing SQLs. That's all about this Spark SQL. So the advantage is the coding complexity is less and read less data, and optimizer do the hard work. Okay. And it's easy to seamlessly mix SQL queries, and it can provide this Hive capabilities also. Means as in the last session I told, this Hive is a SQL flavor on top of this HDFS file system. Okay, so this has all this SQL capabilities in the Spark SQL, and then Spark streaming means okay, streaming of data. So enabling the streaming capabilities on this data means nowadays we need to, if you see Twitter or Facebook or WhatsApp, all these are the data streams. Okay, your friend is sending a message, immediately you are receiving. Okay, so all this data is getting streamed. Okay, let's take your kid bus started from school, immediately there is a automated communication will come to all the parents that the bus started, and you can track that also the bus. Okay, so same thing that flights, we can able to track that flights, means it will show that where it's traveling and everything. So this streaming of this data, run a streaming computation. So what they are doing the streaming is they're chopping the data into a kind of partitions. Okay, chop up the live stream data into batches of X seconds. Okay, so they're dividing their data into small pieces, and Spark treats each batch of data as RDD. So they will treat each small piece as a RDD, as it's a kind of a small data. Okay, each stream is a small data. That is nothing but we call as RDDs in Spark. Finally, they will process this data, whatever the manner we require. And okay, finally, the processed results, the RDD operations are returned in batches. Okay, so finally, it will accumulate all these batches of data, and it will send as a one complete representation of this data. So here, this key concepts here is a D stream or discrete stream they used to call. Okay, this D stream is a sequence of RDDs representing a stream of data. So if you see this Twitter, HDFS, Kafka, all this, okay, they are using these concepts, and we have this transformations as similarly I told, and we have our output operations. So means we can save as a data as a Hadoop files. We can apply some operation on this data for getting some actions. Okay, so if you see this stream data, we have batches of multiple batches, and it has each one has its equivalent RDD. So it's chopped up data. So why this Spark streaming is, it's very useful for this website monitoring, means how this website, is there any peak load, or whether there's any chance of websites to go down. All this can be monitored. They can take a corresponding action. They can increase the RAM to make sure that the websites are not going down and all that. So nowadays, cloud came in picture. If the load is high, they will initiate that automatic addition of that processing engines. Okay, and this fraud detection. Okay, if, nowadays banks and all these people widely using this to identify if there is any spams or frauds on the transactions. And ad monetization. Okay, so for advertising purpose and putting the right advertising. Some people may interested in the something, so they need to put that right advertisements for the ad monetization. All this purposes Spark streaming is used. Okay. So now let's come to that. Okay, two of my friends, they were unconscious. Okay, let's see what they are doing now and what Spark can do for them. Okay, so.
Sir. Sir. Hello, sir. Hello, sir.
Hello.
Oh, yeah. Hello, carry on, sir.
Yeah, are you able to hear me?
Yeah, now it's okay.
Okay. So,
Hello.
Hello.
Yeah.
Yeah.
Okay. So, as I said, okay, so this guy, his car got he got a little bit. He was since he is driving, and after the dinner, he was a little bit drowsy, and his car got upside the road, and it was upside down, and he was unconscious. And since it's a night, no one was recognized him. So after half an hour, he got woke up, and he called to his brother, and he told that I am not sure where I am. Okay, I was 10 minutes back. I started from this place. Can you please come just you start coming, just check outside the road, and I don't know where I am. So his brother and he came up with some group of people, and finally they caught him and they took him to the hospital. And luckily he got some neck injury and he recovered. And the other guy who was met with the truck, iron ore truck, the air balloons got opened. And luckily that local people who were standing near to them, they came and they hitting that his car. It's completely locked. He was unconscious. Everyone outside, they are shouting at him. And after some time he woke up, and he opened the door, and luckily he didn't have major injuries. Okay, so what these are the things is, okay, this kind of situation called, there sometimes the injuries will be very serious. So the golden hour in this accident means within 25 minutes we need to take the action. Okay, then only we can able to save life if the people got any injuries. Okay, this is the WHO standards. Okay, so if we look into the worldwide standards, worldwide statistics, okay, so the response time majorly whenever this kind of accidents happen worldwide, so the trespassers, whoever that nearby walking around, that those kind of people only communicating to either police or medical, or they only opening the doors or breaking the car and helping them. Okay, and then this statistic, this rescue time here is that it's a notification time to emergency medical system, and then response time means once the accident happen, sometimes that person can able to call and inform this emergency medical system, or some tripasser need to, means there is a wastage of time. Let's say if half an hour no one came, so there is his likelihood of survival will be difficult. Okay, so once they notify, okay, it is taking some response time. This response time, if you see in America, it's taking 9 minutes on average. In Europe, it's taking around 9 to 10, and in Asia around 7 minutes. And whereas in Africa, sometimes it's 5 or 20 minutes. Okay, so what this means is, okay, we have all the data, we have the connected devices, we have satellite way of tracking that. Okay, so if we able to enable this, okay, this is onboarding diagnosis data we used to call. We have IoT device left side, and real-time onboarding diagnosis of data. If we able to stream this data with the technologies like the NiFi and Kafka, and with the Spark streaming, and with this we can able to alert the people either to this medical representatives or police or friends or relatives. Okay, so this need to be automated. Okay, there is a huge opportunity in this space. Okay, people are working something, but still there is opportunity to extend this solution. Okay, so this kind of places, this Spark is very useful. The two examples I told, it's a real-time example of my friends. And the first guy, who are that insurance agent, and he is a second time he drove that car along with the family. We warned him, don't drive again, and used some experienced driver if we want to. But he has not listened. The second time again he went, And unfortunately, this time he met with another accident. He himself, his wife, his daughter and son, all the 4 people died on the spot. And he loves his family, and along with him, he taken his family also. And he loves his brother, and whatever the property he earned, he left to his brother and his brother's family. Okay, so there are huge opportunities for this streaming data. Okay, so that's why I thought of telling this real-time example. What are the kind of use cases this Spark can give us? Okay, if you look into this flights, they are running hours together continuously, 14, 15 hours from US to India. And to do that maintenance in this journey, is there anything got damaged? Okay, what they are doing is each hour it will generate petabytes of data, and the data is getting processed using this Spark and big data technologies. They are identifying that if there is any repair is required, immediately they will send the technician, and they will say that so and so place there is something, the wires has broken, you need to go and fix it. So all this is because it's a big data, and the Spark is helping a lot in many places. Okay, so and there is, if you see in the recent news, this TalkTalk is a company in the UK. So because of COVID, now everyone is working at home. So they want to track that whether these people are really at home or they are outside into some shopping or in some cinema theater. So they given a RFID to each of their employee. They are asking them to carry this RFID to monitor them. Okay, and also in the UK, there is a plan to microchip this to cats to track this cats. And also there is another proposal in the UK. There are many people going to UK, and all the people are not returning back to their countries after completing their visa period. So there was a proposal that they want to chip each individual who is coming into UK to track them, whether they are leaving the country or not. It's a kind of violation of individual freedom and all that, but there is a people are thinking at that level. And even if you see this middle one, this US, they want to collect a DNA, eye scan, and a voice print from immigrants. They want to track that what this guy is doing in this country. Okay, they want to track at that bottom level. And there is a flying taxi in Paris. So the cop asked that flying taxi to bring it down because he's speeding in while flying. Okay, so that's kind of tracking people are doing. So you saw the recent Olympics in Japan. Okay, it was they have just done to do the Olympics to complete. Okay, there was no opening ceremonies or closing ceremonies, no, not much recreation for participants or viewers. Okay, so there is a huge, they planned so many things, but they were not able to do because of COVID. Now this 2024, it's a Paris turn. Okay, so they are going to conduct this other Olympics. So they have many responsibilities to make sure that the people get satisfied. Whatever happened in Tokyo should not repeat. Okay, and so they have plans to bringing the athletes using the flying taxis to the Olympic stadium. Okay, so these are all. Why I'm saying is everything is connected devices. They are streaming the data. They are tracking everything. So that's where the world is going ahead. If I say, okay, earlier we used to see these kind of stories in movies like Star Wars kind of movies. Tomorrow, the flying car in middle. So this is a reality is going to happen. And this is SpaceX that Elon Musk is working. So he has a plan for this Starlink. Okay, he's planning to provide the internet to home to using the satellites. Both Jeff Bezos from Amazon and Elon Musk from the Tesla, they are working on towards that. Okay, and this the car is flying. This in 2018. Elon Musk sent his car into space. The idea is when he goes to space, he wants to use his car. Okay. And all this, so many examples, so many things is going in the streaming side. So the advanced technologies, okay. So AWS EMR, if you look into this, the cluster configuration is a very difficult activity. Okay, as I said, okay, so to identify how many name nodes and how much RAM I need to use, how many executors I need to use. It's not, this is simple calculation I have done for one of the projects. It's so difficult, okay. So there is Amazon has this EMR, and Azure, they came up with this Databricks, and they funded 250 millions in this Microsoft funded for this Databricks, and they came up with the data lakes and for processing batch and streaming data. And this Netflix and Apple, they invested a lot of money, and they extended this Spark to come up with this Iceberg, Apache Spark. Same thing from Uber. Okay, they have extended and they came up with Apache Hoodie. It's nothing but Hadoop, upset, delete and insert. Okay, this is, and another company called Snowflake, they use this cloud capabilities with AWS, Azure, and Google, and they use this underlying architecture of Spark. They came up with this Spark cloud data warehouse. They have this inside one is this data storage, and then the middle one is this processing layer. Outside is the service layer. Earlier, all three is connected together. Now they have separated, and with that, they are achieving a lot of performance, and many customers are using this one. Okay. So that's all I have pretty much. Okay. And yeah, I hope you guys at least got some basic idea on that Spark, how it is using, and what are the concepts are there, and who are the people are using. And there are a lot of opportunities as of now for streaming. Okay, Spark is one of the best, along with Kafka, NiFi, and the stream sets. Okay, this technology has a lot of opportunity to evolve. As I shown earlier, so many companies are investing, big companies like Netflix, Apple, Uber, okay, and Microsoft, Azure, Amazon, all big players are using these technologies. Okay. So that's where this people are paying, like a 5 years guy is getting 50 lakh salary in India itself. Okay, who are working on this technology. That kind of opportunities are there in India itself. Okay, so if you want to come up, do some better in your career, you can learn these technologies, and yeah, good luck to everyone. Okay. So this is my contact info. Okay, stay safe and take care. So any questions, anything? Yeah.
Participants can unmute themselves and speak or post their queries in the chat box. Okay, sir. That was an interesting session. Thank you very much, sir, for the valuable knowledge that you have shared with us. I sincerely take this opportunity to express my gratitude to you and all the participants on behalf of IEEE Malabar Subsection for joining us. I request the participants to fill the feedback form before leaving. Thank you again.
Yeah, thank you very much. Yeah.
Thank you, sir. Thank you, sir.
Thank you for the opportunity. Okay.